warehouse is located at a point A and the delivery destinations are given by U, V, W, X, Y, Z. Corner point feasible solution, that is called as CPF. All the variables should be greater than or equal to 0. This is called as non-negativity constraints. This technique of choosing the shortest route is called as linear programming. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. In my last session, I have discussed about the role of OR in decision making and general method for solving OR models. And also have discussed about the basics of linear programming problem called LPP. So what is LPP? LPP stands for linear programming problem. It is very important concept in operation research. So what is this linear programming? So today I am going to discuss about the following topic called basic solution, basic feasible solution, unbounded solution, limitations of LPP, applications of LPP and advantages of LPP. In my last session, I have discussed about the introduction of LPP. So linear programming is one of the simplest ways to perform optimization and it helps you solve some very complex optimization problems by making a few simple assumptions. So LP stands for linear programming problems. So why we are using this LPP? So it is a simplest way to perform optimization and it helps you solve some very complex optimization problems in a simplest way. So what is the role of this LPP in our real life? I will give an example for LPP. Let's say a delivery man has 6 packages to deliver in a day. The warehouse is located at a point A. Example, a warehouse is located at a point A. The 6 delivery destinations are given by U, V, W, X, Y, Z. 6 delivery destinations are given by U, V, W, X, Y and Z. So here I am using the numbers on the lines. It indicates the distance between the cities. To save fuel and time, the delivery person wants to take the shortest route. Right? So a delivery man has 6 packages to deliver in a day and the warehouse is located at a point A. Warehouse is located at a point A and the delivery destinations are given by U, V, W, X, Y, Z. So here I will mention the number of lines. It indicates the distance between the cities. For saving the fuel and time, the delivery person wants to take the shortest route. Clear? So what is the role of LPP in the structure? So what is the role of LPP here? So this LPP will help to take the shortest route. So this LPP helps you solve the very complex situation, right? So using this LPP method, the delivery man can save fuel and time. So how we can save the time? So he can choose the shortest route to reach the destination. Clear? So the delivery person can choose the shortest route for reaching the destination, right? So this technique of choosing the shortest route is called as linear programming. So here the delivery person can save fuel and time for choosing the shortest path. Clear? This technique for choosing the shortest route is called as linear programming. So this is one best example for linear programming. So this linear programming helps you solve the complex situations. Clear? So this is called as linear programming problem. So here we have some important definitions used in LP models. So what are the definitions of LP models? Let us understand one by one. So first one, we have solutions. So first we have to find the solutions for a given problem. A set of variables. So here we have to select a set of variables. So we have different variables. Example, x1, x2, x3 up to xn. is called a solution if it is satisfies the constraints. So this is called as solution if it is satisfies the constraints, then we can call it as solution. So example, we have different variables called x1, x2, x3, y1, y2, y3, z1, z2, z3. If this variable is satisfies the different constraints, then we can call it as it is a solutions. And feasible solution. What is this feasible solution? A set of variables called x1, x2, x3 up to xn is called a feasible solution if these variables satisfies constraints are non-negative. So when we can call the feasible solution? If the set of variables satisfies the constraints are non-negative. If it is non-negative, then we can call it as it is a feasible solution. While I am doing the graphical, so while I am explaining the graphical method using LPP, then I can show you the feasible solution, infeasible solution, unbounded solution in detail. So next concept we have basic solution. So what is this basic solution? A solution obtained by setting n variables among n plus n variables to 0 and solving for remaining m variable is called as basic solution. So here we have to consider the set of variables. So example, it can be m variables or n variables. So it has to satisfy the remaining variables, then we can call it as basic solution. While we are solving the LPP problems, then easily we can understand about the basic solution, feasible solution, etc. And basic feasible solution called as BFS. Very important question for 2 mark. What is BFS? Basic feasible solution. So, basic feasible solution if all basic variables are greater than or equal to 0. So, already I have told you that it should be non-negative. All the constraints should be non-negative. That means all the basic variables is greater than or equal to 0. Example, if I have x1 plus x2, x1 plus x2 variables. So all these x1 and x2 variables should be greater than or equal to 0. Then it is called as BFS, basic feasible solution. So all the variables should be greater than or equal to 0. That is called as non-negative constraints. And next we have non-degenerate basic feasible solution. If it is a basic feasible solution in which all m variables are positive and the remaining n variables are 0. So all m variables should be positive and the remaining n variables are 0, then we can call it as it is non-degenerate basic feasible solution. And degenerate basic feasible solution. It is a basic feasible solution in which one or more of the m basic variables are equal to 0. So, example, x1 plus 2x2 is equal to 0. So, here I have written the degenerate basic feasible solution. So, variables are equal to 0. And the next one we have optimal basic feasible solution. A basic feasible solution is called the optimal basic feasible solution if it is optimizes the objective function. If it is optimizes the objective function in the sense, so it has to optimize the objective function called, it can be maximization or minimization. Example, max is equal to 2x1 plus 3x2. So it is called as objective function, or min is equal to 4x1 minus 5x2. So it is called as maximization objective function and this is minimization objective function. So if your optimal basic feasible solution has optimizes objective function, then we can call it as optimal BFS. So everything you will understand in detail in problems. So next we have unbounded solution. If the value of the objective function in the sense it can be maximization or minimization, can be increased or decreased indefinitely, then the solution is called an unbounded solution. So if your optimal solution objective function can be increased or decreased. It has to be, so it can increase or decreased indefinitely, then we can call it as it is unbounded solution. And what is feasible region? So it is a region in which all constraints or non-negativity constraints are connected. So here I can call it as it is feasible region. So here the first constraint, this is the first constraint and this is my second constraint. So here both the constraints are connected each other. This region is called as feasible region. So this thing I will explain in a graphical method. And the next one we have corner point feasible solution, that is called as CPF solution. It is a feasible solution that does not lie any line segment connecting two other feasible solutions. So here I got a feasible region. So for this feasible region I have shaded the point. So here I got two more region called corner feasible solution. This is called as corner point feasible solution. So for connecting the feasible region, we got the corner point feasible region. So this is about the basic definition of LPP. And the next concept we have optimization. It is a technique of obtaining the best results under the given conditions. So here we have to obtain the best results for a given problem. That means it is optimization. So everything depends on optimization. And programming, it is a mathematical technique to determine the optimum use of the limited available resources. So programming is a mathematical technique to determine the optimum use of the limited available resources. So here for representing the optimal solution, we have to choose a limited available resource for representing the programming. So next concept we have, very important concept, the common terminologies used in LPP, linear programming, the common terminologies. So in my last session I have discussed about the basic requirements of LPP. So this is a common terminologies used in linear programming. So first one we have decision variables. So here we have to use a decision making concept for representing, for considering. So here we have to choose a better decision making concept. Here we have to mention the decision variables. The decision variables are the variables, example x1, x2 up to xn. It is a variables will decide my output. So this variables will decide the final output. They represent my ultimate solution. So example, if your optimal solution max z is equal to x1 minus x2, x1 minus x2. So here I am using two basic variables. So decision variables. So this decision variables helps to solve any problem. So first we need to identify the decision variables. For example, the total number of units for A and B denoted by x and y. Example, total number of variables, I am choosing A and B. So here I am using, for representing total number of variables, I am using A as a x and B as a y. So this is called as my decision variables. And objective function, it is defined as the objective of making decisions. So this is very important for representing the objective functions. So here we have to find the objective function, whether it is maximizing the profit or minimizing the loss. So here we have to choose a better objective functions. Example, the company wishes to increase the total profit represented by Z. So profit is my objective function. So max Z, profit is my objective function. Max Z is equal to, so here I am using x plus y, because number of variables represented by x and y. So max z means total profit I am expecting here. Max z is equal to x plus y. This is called as objective function. So this is objective function and decision variable. So how many variables have to choose in my problem? So this is a basic structure, and the next one we have constraints. Very important concept is constraints. The constraints are the restrictions or limitations on decision variables. Whatever the decision variable you are taking here, so it has to be restricted in constraints. So here, for representing the constraint, have to use the value of the decision variable. So here also I need to use the decision variables called as x1, x2, y1, y2, etc. So here I am taking the better constraints for representing the problem. Example, the limit on the availability of resources milk and choco are my constraints. So here have to choose the availability. So here for representing the better constraints have to choose the availability of a given product. Example, here I am using two constraints, that is x1 plus x2. Then what is the availability for milk and choco? So my availability is 500 and 400. So availability is 500, and for second product availability is 400. So this is called as constraints. This is an example for constraints. So next one is non-negativity restriction. So how to represent this non-negativity constraints? For all linear programs, the decision variables should always take non-negative values. It should be non-negative values. That means it should be greater than or equal to 0. This means the values for decision variable should be greater than or equal to 0. So here I am using 4 variables, basic variables, that is x1, x2, y1 and y2. So all the decision variables should be greater than or equal to 0. So here I have used the LPP structure. So first have to mention the optimal solution. So first I have to find the optimal solution. It can be maximizing the profit or min. Example, x1 plus x2. This is optimal solution, and here I have to find the constraints for a given problem. This is an example for constraints. First you have to choose a better decision variables. So here I have given one example, x1 plus x2 less than or equal to 500. So what is this 500 and 400? It is the availability of the product. And all the variables should be greater than or equal to 0. This is called as non-negativity constraints. Non-negativity constraints. And this is constraints, and this is objective function or optimal solution. So this is a basic structure of LPP problem. While we are solving the LPP problem, the structure is very important. So first you have to mention the optimal solution and constraints, and you have to mention the non-negativity constraints. So here for solving LPP problem, we have to identify the decision variables. It can be x1, x2, or it can be product A or product B, etc. And we have to write the objective function. Objective function means maximization of product, that is x1 plus x2 or y1 plus y2, etc. And mention the constraints. First we have to check the availability of the product. Example, x1 plus x2 less than or equal to 500 and y1 plus y2 less than or equal to 400. So this is an example for constraints. And explicitly state the non-negativity restriction. So all these variables x1, x2, y1, y2 should be greater than or equal to 0. This is called as non-negativity constraints. So this is the basic structure of LPP. Decision variables, objective function, constraints and non-negativity constraints. If all the conditions are satisfied, it is called a linear programming problem. It is very simple concept. Easily you can solve the linear programming problem, but you have to use these steps for representing the linear programming: decision variable, objective function, constraints and non-negativity constraints. And the next concept, we have advantages of LPP. So already I have explained one example how to find the shortest path, right? So that is the best example for finding linear programming problem. So using linear programming problem, we can find the shortest path and we can simplify in easy way, and we can find the easiest way to representing the problem. So what are the advantages of linear programming? LP makes logical thinking and it provides better insight into business problems. So this linear programming can help you to solve the business problems. So linear programming is used to minimize the cost of production for maximum output. Keep in mind, this linear programming is used to minimize the cost of production for maximum output. In short, with the help of linear programming models, a decision maker can most efficiently and effectively employ his production factor and limited resources for get maximum profit at minimum cost. And manager can select the best solution with the help of LP by evaluating the cost and profit of various alternatives. So using LP models, so managers can select the best solution. Clear? And LP provides an information base for optimum allocation of scarce resources. So this LP provides an information base for optimum allocation of resources. And LP assists in making adjustments according to changing conditions. LP helps in solving multidimensional problems. So this LPP solve the multidimensional problems. So this LP solve the multidimensional problems also. So these are the advantages of linear programming. Very important questions. What are the advantages and disadvantages of LPP? 7 marks question. And the next concept is limitations of LPP. So it is not easy to define a specific objective function. So it is not an easy task to find the objective function for a given problem. And even if a specific objective function is laid down, it may not be so easy to find the various technological, financial and other constraints. So linear programming can be applied only when the objective function and all the constraints can be expressed in terms of linear equations or inequalities. So linear programming is not an easy task to specify objective function. So these are the limitations of LPP. And the next concept, last concept is applications of LPP. So in which area we are using this LPP model? So food and agriculture, applications in engineering, transportation optimization, efficient manufacturing. Very important applications of LPP. Very important question for 8 marks. So first application is food and agriculture. Farmers apply linear programming techniques to their work by determining what crops they should grow, the quantity of it and how they efficiently farmers can increase their revenue. So it is helpful to food and agriculture also. And the next one is applications in engineering. So in engineering also we are using this LP model. Engineers also use linear programming to help solve design and manufacturing problems. For example, in airfoil meshes, engineers seek aerodynamic shape optimization. This allows for the reduction of drag coefficient of the airfoil. So, engineers also using this linear programming to help solve design and manufacturing problems. And the next application is transportation optimization, very important applications of linear programming problem. Transportation systems rely upon linear programming or cost and time efficiency. Bus and train routes must factor in scheduling, travel, time and passengers. Airlines linear programming to optimize their profits according to different seat prices and customer demand. So this LPP is helpful in transportation systems. And the last one is efficient manufacturing. Manufacturing requires transforming raw materials into products that maximize company revenue. Each step of the manufacturing process must work efficiently to reach the goal. For example, raw materials must pass through various machines for set amounts of time in an assembly line. So this manufacturing requires transforming raw materials into products that maximize the company revenue. So these are the applications of LPP. So first one, food and agriculture, applications in engineering, transportation optimization, and last one, efficient manufacturing. So these are the applications of LPP. So today we learned the basic structure of LPP and some important definitions of LPP and advantages, disadvantages and applications of LPP. So we have understood the concept of LPP, right? So in my next session, I will discuss the problems on LPP. Thank you.